Well, we'll conclude this lesson with three fairly simple integration problems, but I did want you to see that you don't always need calculus to find areas. But what we find when we use calculus does jive with what we would use in geometry. Not all areas we would seek would be these bizarre shaped regions like the one in the preceding problem, which had an area of 10/3. It's hard to imagine that this piece between the blue and the green in this first quadrant is 10/3, but that's what we found out. But what about this one? The region in quadrant 1 below the graph of y equals 2x on the interval from 0 to 4. Well, hopefully you should say, well, the graph of y equals 2x is a line with slope 2 going through the origin, and on the interval 0 to 4 means it's a right triangle with base 4, and height is actually 8, because if x was 4, y would be 8. And so right triangle with height 4 and base 8, actually any triangle with height 4, wait a minute, let me say that the other way, height 8 and base 4, the area is 1/2 of 8 times 4, which is 16. But notice if we did calculus, area from 0 to 4, 2x dx is integrating 2x is x squared. And put in 4, we get 16. Put in 0, we get 0. 16 minus 0 is 16, so it's just what we thought it would be. Interval from 0 to 6 of 3 dx. Well, integral of, by the way, maybe you should think through this one yourself first. Region in quadrant 1 below the graph of y equals 3 on the interval from 0 to 6. So this is a rectangle with length 6 and width 3. By the way, as a mathematician, I've never been afraid of heights, but I am afraid of widths. So that's just a 6 by 3 rectangle, so naturally we should get an area of 18. And if you do the integration properly, area from 0, or integral from 0 to 6 of 3 dx is 3x. From 0 to 6 is 3 times 6 minus 3 times 0, which is 18, and that's easy to see that one. Okay. A little more complex is this one. The region in quadrant 1 below the graph of y equals 2x on the interval from 2 to 6. Well, if we just integrated it, it's the same integral as this one. So it's x squared going from 2 to 6. Well, that means it's 6 squared minus 2 squared, which is 32. But what we have here is a triangle with base 4 and height 8 sitting on top of a 4 by 4 rectangle. And the area of that would be 1/2 of 4 times 8 plus 4 times 4, which means it's 16 plus 16, which is 32, just what we got when we integrated it. I've got pictures of all three of these down here if that didn't make sense to you what we did above. Here's the first problem. It was a triangle with base 4 and height 8. So the area was 1/2 of 8 times 4, half base times the height. This was a rectangle of length 6 and width 3. I know in my picture it looks like a square, but if you notice the scales aren't the same. Nor are they the same with this one. This is actually a 4 by 4 square at the bottom, which has area 16, and this triangle is actually the same dimension as this triangle here. It's 4 this way and 8 this way. So again, it's the 16 from this part plus the 16 from this part. And you should see that geometry gave us every one of these answers. We did not need the calculus, but the results were the same.